All right, we're going to now look at a linear first order ordinary differential equation. So here's the example I've chosen. We're just going to firstly verify that this is indeed linear. Remember that linear means that there's no product of the derivatives of the dependent variable or no products or functions of the dependent variable on its own. So this dy dt, that's on its own. No functions or products. This is on its own as well. There's no products, there's no powers, nothing. These are functions of the independent variable. And that's all good. That doesn't affect the linearity of this equation, provided that the dy dx term and the y term are linear, we're done. So this is indeed a linear equation. Recall that any linear equation can be written in the following form, and this is just the notation we've adopted in the course. Sometimes you see different notation used. Right, so that's what's called the canonical form. And the reason we like to write things in canonical form is so we can identify p, which is this function here, and q, which is this function there. So for our example, we note that p of x equals 3x cubed, and q of x equals 6x squared. We also know that we use what's called an integrating factor to solve these equations. So in our notation, it's r of x is the integrating factor. That's e to the power of the integral of p of x dx. And that's why we identify p and q, because we need to know what p is in order to write down the integrating factor. So I'm going to scroll up now. And I'm going to work out what this actually is, because we know what p is. So that's e to the integral 3x cubed dx. Oh, oops, I've made a typing error. That should just be a squared. Sorry, I got carried away. So 3x squared, we integrate 3x squared, we end up with 3x cubed over 3. Which is just x cubed. Remember also that we do not need a constant of integration. A constant of integration would pop out the front of this rx, and when we multiply through, it would all divide out anyway. So we do not bother with the constant of integration. And that's our integrating factor for this problem. Now, remember that the integrating factor, what we do is we multiply through our equation by the integrating factor, like so. And now we use the integrating factor's property that this is, oh, oops, sorry, I forgot to, no, please close, sorry, E, by the property of the integrating factor, this left-hand side becomes like so. Now that means we can integrate both sides with respect to x and simplify. Integrating the left-hand side with respect to x just removes the derivative. Okay, this integration we have to do by substitution. We're going to let u equal x cubed. Then du equals 3x squared. And we can see how to rewrite this integral. That's equal to integral 2 e to the u du. All right, so note that I've just taken out a factor of 3x squared, or alternatively, you can write dx equals like so. Okay, now we know how to do this integral. We substitute our value of u back in. Oops. Like so. And now our goal is to simplify. So we've got this factor of e to the x cubed on both sides. So I'll just copy this down because I can't see my solution anymore. And I'm just going to divide throughout by e to the x cubed. A very popular mistake is to forget to divide the constant by e to the x cubed, and I'm just changing my index using my index laws. But there we have it. That's our solution to this problem.